All right, so today I'm going to show you how to use T-charts to convert between more complex problems. So we've converted moles to grams, and then we kind of sidestepped and talked about dimensional analysis, which involves the conversion of units and numbers with a little bit more familiar units like years and months and days, and also a little bit more complex problems. And we're going to kind of steer back to chemistry and talk about stoichiometry. So stoichiometry is just kind of a fancy word for chemistry math, and it's the mixture of unit conversions and chemistry language and T-charts and kind of just putting everything together. So in this situation, there are three relationships that we need to know. First of all, 1 mole equals the molar mass of a substance in grams. We already know that. 1 mole is also equal to 22.4 liters, and this is at STP, which stands for standard temperature and pressure conditions. So this value is only usable if you're at STP, and the questions should state at STP. And then 1 mole equals 6.02 times 10 to the 23rd particles. That number right there is called Avogadro's number. Avogadro's number is a way to convert from moles to particles, and in this case, particles, the word is the same thing as molecules, is the same thing as compounds, so if you see those words, they're interchangeable or synonyms in this context. The reason why we were talking about scientific notation is because of this value right here, so that we know how to use it in our calculators and convert in and out of scientific notation. So the first problem says convert 12.3 grams of CH4, which is methane, or carbon tetrahydride, into molecules. And so we have to have a starting place and an ending place. Whatever has the number is our starting place, so this is what we know or are known, and we're trying to convert it into molecules, which is our unknown. So you always start with your known, put it into a T-chart, and in this context, I really need to know what this compound is because I have to convert out of grams, and the only place to go is the mole, and so I'm going to need the molar mass of the substance. So it's 12.3 grams of CH4 or methane. Set that up into a T. I know that these units have to carry down in order to cancel out, and I need to kind of sidestep really quick and calculate the molar mass of methane because this top relationship says the molar mass in grams is equal to 1 mole. So carbon is 12.01, and then there's 4 hydrogens. Each one of them is 1.01, so 1.01 times 4 is 4.04. Add those together, you get 16.05. So that value goes here. Oop. Now that we are in grams, now that we've canceled out our grams and gotten into the mole, let's look at our conversion chart and figure out how we're going to get to molecules. All right. So our conversion chart, if you look on the left side, says known substance, substance A. What we just did was we converted out of grams into the mole by dividing by the molar mass. So if you follow the blue arrow going down to moles. Now what I want to do is I want to go to particles, knowing that particles and molecules are the same thing. And so if you trace the arrow going from moles to particles, on the top it's pink, it says you need to multiply by 6.02 times 10 to the third. So that's what I'm going to do, but I'm going to put it into the T-chart. So I need to multiply by 6.02 times 10 to the 23rd molecules. Therefore, it has to go in the numerator because anytime you multiply something, it's in the numerator, and anytime you divide, it's in the denominator. Well, I don't have anything down here right now, but I do know that this value is equivalent to 1 mole, which makes sense because I need to cancel out those units anyways. So the only unit I have left is what I was looking for, so I stop and I calculate, and I pull the unit that I have left over into my answer, like that, and then I calculate it. So I take the known, which is 12.3, multiply it by Avogadro's number, oopsies, 6.02 times 10 to the 23rd. Those are all the values in my numerator, so I press equals, and then immediately divide by what's in my denominator, which is 16.05. And you see how I get a number in scientific notation, which makes sense because we're talking about molecules and they're tiny, so of course there's going to be a lot of them, times 10 to the 23rd. This E right here stands for times 10 to the power of, so don't let that confuse you. So I'm going to round this to 4.61 times 10 to the 23rd. 4.61 times 10 to the 23rd, and that's my answer in scientific notation. All right, next problem. Convert moles into volume. So my known is 0.10 moles, and I want to convert that into volume. Well, I know that the relationship up here states that 1 mole equals 22.4 liters. So I can use that relationship. 1 mole equals 22.4 liters. You put one on one side, one on the other side. The reason why moles goes down there is because it needs to cancel out. Well, I reached the units I was looking for, therefore you just take 0.1 times 22.4, and your answer is 2.24. So you just move the decimal place over one time. And it's volume, so my units are liters. So sometimes they take multiple steps, sometimes they just take these 2 steps, and you really just need to figure out what you're converting. Next one, convert 4.73 times 10 to the 23rd particles of sodium chloride into mass, which is going to be measured in grams. So this problem is exactly the opposite of this one up here, the first problem. So you have 4.73 times 10 to the 23rd particles. We'll abbreviate particles part. Set that up into a t-chart. I know I need particles down here. Whatever this unit is has to carry down. Well, if I look at my relationships up here, I cannot go directly from particles to molar mass or mass. I have to go through the mole. So 1 mole equals 6.022 times 10 to the 23rd. So I know, and that's in particles, so 6.022 times 10 to the 23rd has to go in the denominator for every 1 mole up top. So I haven't reached mass yet, so I'm going to keep going. Well, I know that 1 mole equals the molar mass of a substance, so I'm going to put 1 mole is equal to the molar mass of sodium chloride. So I need to stop. Sodium chloride is 22.99 for sodium, and chlorine is 35.45. You get 58.44. That's the mass in grams of sodium chloride. So then just reevaluate. This unit cancels out with this unit. The only unit I have left is the mass of sodium chloride, which is exactly what I wanted, so that pulls into my answer. And then I do the math. So I have a scientific notation value in the numerator and one in the denominator. So what I'm going to do is take my first number, 4.73 times 10 to the power of 23rd, multiply it by whatever my other numerator is, times 58.44, press equals, then divide by my denominator. So then I'm going to divide by Avogadro's number, which is 6.02 times 10 to the 23rd. Oops. Oh, that's right. Okay. My answer is 4.59 times 10 to the 47. That's wrong. Anytime you get a times 10 to the anything, automatically rethink that. I'm sorry, times 10 to the 40 anything, rethink that. So what I'm missing here are parentheses. So what I'm going to do is recalculate this. Parentheses, 4.73 times 10 to the 23rd times 58.44 equals, and then divide parentheses 6.02 times 10 to the power of the 23rd, close your parentheses. That's a totally different number than what I just got. So if you ever get a times 10 to the 40 something, put the brakes on, it's wrong, recalculate with parentheses. So this answer is 47.9, which makes sense because we're talking about mass, so that's a logical number for mass. 45.9 grams of NaCl. So the numbers have to be reasonable. If they're not, rethink it. Lastly, last problem. We're going to convert 6.3 times 10 to the 22 particles of O2 gas into liters. So this would be a quick 2-step problem. So you start with what you know, times 10 to the 22nd particles. Again, I'm going to abbreviate particles part. Set it up into a t-chart. And I'm going to get out of this exactly the same way I did up here. The only place I can go is into moles. So I know that 6.022 times 10 to the 23rd particles is equivalent to 1 mole. Those units immediately cancel out. Now that I'm in the mole, I can go to volume. Well, I know up here, given this relationship, is that 1 mole equals 22.4 liters. So I know that 1 mole down here equals 22.4 liters. This unit has to go down here because it needed to cancel out up there. You stop when you reach the units that you're looking for, which is liters, and then you calculate it. So automatically I have numbers in the numerator and the denominator that are scientific notation, so I'm going to use parentheses. So I'm going to take 6.3 times 10 to the power of 22 multiplied by 22.4 equals divide by parentheses Avogadro's number 6.02 times 10 to the power of the 23rd. And I get the number 2.34, round 2 places past the decimal. 2.34 is a good number for volume. That number is logical, so I accept it. And that's all there is to it.